Hello there, my name is Martin Brezhniak. I'm a second-year software engineering student at York University. Today, I'm going to be talking about the Crystal Clear Air Monitor, a device created by yours truly. Was it easy to make? Absolutely not. In order to create it, I had to work with a ton of stuff that I had, never worked with before. And in order to learn those things, I had to go on the internet, look at websites, YouTube videos, just do a lot of self-learning, essentially. But in the end, I was able to successfully create the project, and that self-learning mentality will surely help me in my future career.
The Crystal Clear Air Monitor is an air quality monitor with data logging. Its main purpose is to allow users to measure the air quality of rooms around their home, workspace, etc. These values can be stored on a micro SD card for the user to review later. It is similar to the AirThing, a device my family actually bought and was the main inspiration for this project. The AirThing made it difficult for users to collect air quality data from different rooms. My device does not have this. This is the schematic of the Crystal Clear Air Monitor. Right in the middle, you could see the Arduino Duo board that was used to create this project. The LCD screen and the 3 LEDs are the main sources of output for the device. The 3 buttons are the main source of input for the device. However, the middle button is currently unused, but that could easily be changed in a future update. Then of course we have the CO2 and VOC detector module and the temperature and humidity sensor. We have a real-time clock module to keep track of time, a fan to circulate air, a micro SD card reader, and an EEPROM chip, which was needed as the Arduino Duo does not have a built-in EEPROM. This component here converts a 3.3 volt signal into a 5 volt signal. This is the flow chart of the Crystal Clear Air Monitor. After it runs through some setup to check and see if the microSD card and the EEPROM are working, it enters the main loop. After collecting data from the sensors, it checks to see if they're good, bad, or average, and then turns on the corresponding LED. It then checks to see if the left button has been pressed. It then checks if the right button has been pressed. It then checks to see if 15 minutes have passed. If it has, it will save the new CO2 calibration value. On top of that, if file writing is enabled, it will also write the current data to the microSD card.
This right here is the Crystal Clear Air Monitor in action. As you can see, the date, time, temperature, humidity, CO2, and VOC levels are all displayed on the LCD screen. If I were to blow on the sensors right now, the values would begin to go up, as you can see. Currently, the air quality in this room is good, so this LED is green.
However, in this picture, you could see a moment where the air quality was bad, as the CO2 value went over 1,500.
The user can also enable and disable file writing
by pressing these buttons.
At the moment, it is disabled, so that button is red. At the moment, it is 2:27 p.m. At this time, I am going to turn on file writing. So about an hour has passed, and I am now going to disable file writing. So about another hour has passed at this point. I will now then turn back on the file writing, and then we'll take a look at what the actual data looks like on this micro
SD card. This right here is what the inside of the file looks like. As you can see, each file is named after the date it was recorded on. So we're going to go ahead and click on this file. This is what the inside of the file looks like. As you can see, we have the date, the time, the max-min average of the temperature, max-min average of the humidity, max-min average of the CO2, and max-min average of the VOC. To show off that the file writing, enabling, and disabling actually works, I went ahead and colorized some of these bits. In the previous clips, it was 2:27 when I turned file writing on. And as you can see, 1 minute later, it recorded a new set of data. It then went ahead and recorded for about 4 cycles. Then, at 3:19, I went ahead and turned it off. This right here was the very last point in which this was the very last data set that got recorded before being turned off. You can then see there's a big time jump to here, as the next time I turned it on was 4:22. The calibration value of the CO2 sensor is also stored on an EEPROM chip, so that when the system is rebooted, it doesn't start off at its default value of a CO2 of 400 and a VOC of 0. The case of the Crystal Clear Air Monitor is a slightly modified version of a 3D model created by GitHub user TinCat. Credit goes to them for making the case. I originally planned on having two microSD card readers. One of them would store the CO2 calibration value, and the other one would store the data for the user. However, despite everything I tried, I could never get these two to work consistently. To fix this, I ended up getting the separate EEPROM chip. I had planned on having the fan run off of a pin. However, the Arduino board's 3.3 volts were not powerful enough to power it. In the end, I ended up opting to have it run all the time. My project could be commercialized by giving it a battery life, essentially, so it didn't always have to be plugged into a wall. Therefore, it could be brought wherever the user wanted. And there is absolutely a market for air quality monitors. In the end, I'd say my project was 100% successful. I included all the features I wanted, and they all work accordingly. Working in COVID-19 did affect my ability to ask for help. However, this in turn improved my researching and self-learning skills.
And thank you for watching.